Welcome to a new video. In this video I'm going to be talking about simplifying roots. Let's say we have a question like square root of 27. So what is the value of square root of 27? In this question we can write 27 as 9 times 3. Okay. In such questions we need to factor this number which is inside the root, okay, as a multiplication of two numbers. And one number should be square of something, like here in this case 9 is square root of 2 times 3. So once we factor this number, okay, which is inside the root, and that number should be written as a square of something times something, and we need to make this number as large as we can. So in this case square root of 9 times 3 can be written as 9 is, as I put it here, 3 squared times 3. So this 3 comes out. Why? Because there is an hidden 2, as we talked earlier. Okay, we can think of this as these are gone. So this 3 goes out by leaving its exponent, and then it becomes free. You can take it in that way. So now it's free. It's 3 square root of 3. Why? Because this 3 cannot go out because it doesn't have any value as an exponent as 2. So it should stay inside. So the result is 3 square root of 3. Let's take a look at another example. For example, let's say square root of 32. Again, we need to factor this 32 as a square of something times a number. If you think 32, it's going to be 16 times 2, okay? So this expression can be written as 16 times 2. We know that 16 can be written as 4 square times 2. And from here, this 4 goes out by just leaving its exponent, okay? So this is going to be equal to 4 square root of 2. You may think that, okay, we can write 32 as, okay, let me write it here. 32 as 4 times 8, okay. This is also possible, but as I said before, you need to write that number as big as you can. You can find the result from this here as well. This 4 comes out as what? 2, right? 2 square root of 8. But we need to keep going to get the simplest form from here. This 8 also can be written as, okay, let me continue here, 4 times 2, right? Because 4 times 2 is 8. So again, this 4 comes out as 2 also. So it's going to be 2 times 2 square root of 2. So 2 times 2 is 4. So it's going to be 4 square root of 2, which gives us the answer as we found before. We have another question. For example, let's say we have the third root of 81. So how we can simplify this expression? Well, again, 81 can be written as 9 times 9, okay? This is the third root. So it's going to be equal to the third root. 9 is 3 square times, there's another 9 which is also 3 square. So this is going to be equal to, if you remember, we are multiplying two numbers and the bases are same, so we just add the exponents. That means the number that is inside the root is 3 to the power of 2 plus 2, which is 4. And we have 3 as a root degree. So from here, I am expanding 3 to the power of 4 as 3 to the power of 3 times 3 to the power of 1, okay? The root degree is still 3. So from here, this 3 comes out by just leaving its exponent. Why? Because its exponent and the degree of the root, they are same. So it's going to be 3 third root of 3. So this is going to be the final answer, guys. Another example, let's say the square root of 125. Again, 125 can be written as 25 times 5. And we all know that 25 is 5 squared times 5. So there is an hidden 2, we all know it. So right now the exponent part of 5 is 2 and the root degree is also 2. If they are same, then this number can go out by just leaving its exponent. So it's going to be 5 square root of 5. So this is the final answer. And another example, let's say we have square root of 64, fifth root of, let's make it fifth root of 64. So what is the simplest form of this expression? Well, we all know that 64 is what? How many twos are there? 6 times, right? 1, 2, 3, 4, 5, 6. If you multiply 6 twos, then we're going to have 64, and the root degree is 5. Fifth root of this number is. Now what I'm going to do is I'm going to add 5 of their exponent parts, okay? The exponents are 1. So this is going to be 1, 2, 3, 4, 5. So from these terms, we're going to have 2 to the power of 5 times 2, and the degree root is 5. And again, as you can see, the exponent of these two and the root degree, they are same, so this number can go out by just leaving its exponent. That means this is going to be equal to 2 times the fifth root of 2. So this is the final answer. Okay guys, here we have a subtopic, adding and subtracting roots. There is a property that we need to obey. In order to add or subtract the roots, the degree of the roots and the inside of the roots should be same. What I mean by putting this expression is, okay, let's say we have square root of 4 plus square root of 2 times square root of 4. Okay, so this is going to be equal to, there is 1 square root of 4, there is 2 square root of 4, so it's going to be 3 square root of 4. In order to add these two roots, okay, the number that is inside the root is 4 in the first term. In the second term, we have the number as 4 also, which is inside the second root. So these are same, and another thing is the root degree. This is square root. This is also square root. Because root degrees are same also, and then we can add them up. And once you add them up, then we have 3 square root of 4. And we all know that that 4 comes out as 2. Okay. So it's going to be 3 times 2, which is 6. Let's say we have another example. Square root of 77, as we learned, can be written as 9 times 3 minus square root of 12 can be written as 4 times 3 plus this is already 3 square root of 3 minus this is already 4 square root of 5. So this 9 comes out as 3, okay? So the first term is going to be 3 square root of 3 minus this 4 comes out as 2. So it's going to be 2 square root of 3 plus 3 square root of 3 minus 4 square root of 5. So here we have 3 square root of 3. Here we have 2 square root of 3. If you subtract 2, you can think the root parts something like this. For example, imagine that square root of 3 is an apple, okay? So 3 apple minus 2 apple is going to be just 1 apple, right? And 1 apple plus 3 apple is going to be 4 apple. So it's going to be this first 3 terms. From this first 3 terms, we're going to have 4 apple, in other words, 4 square root of 3 minus 4 square root of 5. This is gonna be, guys, our final answer. Okay. Why? Because inside of the roots are different, so we cannot go further from here. We can, but how further we can go? Well, in the first term we have 4, and in the second term we have another 4, so we can take the whole expression into 4 parentheses, and it's going to be in the 4 times in this parentheses square root of 3 minus square root of 5. That's the final part that you can go. Okay, but this one and this one, okay, they are same. They are same. So as a result, in order to add or subtract the roots, okay, the inside of the roots should be the same. Let's take a look at another example. So from here, this 8 can be written as, this is 3 times square root of, we all know that 8 can be written as 4 times 2 plus, this is already 2 square root of 2 minus, again square root of 8 can be written as 4 times 2 in the root plus square root of 2. So this 4 comes out as 2 because it's 2 squared, that's why. So once you do that, you have 3 times 2 square root of 2 plus 2 square root of 2 minus, let me put the parentheses again. This 4 can come out as 2, so it's going to be 2 square root of 2 plus square root of 2. From here, we're going to have 3 times 2, which is 6, okay? 6 square root of 2 plus 2 square root of 2 minus. We have 2 square root of 2 plus another square root of 2, it's going to be 3 square root of 2. So we have 6 times square root of 2. We have another 2 times square root of 2, which makes it 8 square root of 2, okay? 8 square root of 2. And if you subtract 3 square root of 2 from 8 square root of 2, then you're going to have 5 square root of 2. Thank you for watching and hopefully see you in the next video.